Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are still on the topic relations, mapping and functions. We've considered relations. In the previous video, we looked at mapping and saw how to find the rule of a linear mapping. In this video, we are going to see how to find the rule of an exponential mapping. So let's look at exponential mapping. In an exponential mapping, the ratio between consecutive elements in the codomain is constant. What does this mean? Let's look at an example. In the previous video, we said that for linear mappings, the common difference between elements in the domain and elements in the codomain are constant. So in this example, you can see that if this were to be a linear mapping, we know that the difference between 1 and 2 is 1, difference between 2 and 3 is 1, difference between 3 and 4 is 1, difference between 4 and 5 is also 1. But let's look at the codomain. Difference between 1 and 4 is 3. Difference between 4 and 16 is not 3. Difference between 4 and 16 is 12. Difference between 16 and 64 is 48. And difference between 64 and 256 is 129. So you can see clearly from here that this is not a linear mapping, because the difference between consecutive elements in the codomain are not the same. So this can't be a linear mapping. So this is an example of an exponential mapping. So it says that in an exponential mapping, the ratio between consecutive elements in the codomain is constant. What is this ratio that we are talking about here? Now let's look at something. Let's divide 4 by 1. So we pick 4 here, we divide it by 1. So 4 divided by 1. I know you know this answer, but let's try it. You are going to get 4. Let's divide 16 by 4. If you take 16 and you divide it by 4, that is also going to give us 4. Let's divide 64 by 4. If you take 64, you divide it by, we are dividing 64 by 16. If you take 64, you divide it by 16, you get 4. Let's divide 256 by 64. If you take 256 and you divide it by 64, that is also giving us 4. Now, do you see what is happening here? You can see clearly from here that if we take consecutive elements in the codomain and we divide them, we are getting a common number or a constant, which is 4. So we take 4, we divide 4 by the previous number, and we are getting 4. We take 16, we divide by the previous number, we get 4. You take 64, you divide by the previous number, you get 4. You take 256, divide by the previous number, you get 4. That is what we refer to as the ratio or the common ratio. So you take 4 divided by 1, take 16 divided by 4, take 64 divided by 16, take 256 divided by 64, and you are getting constant values. So when you have this, we say that you have an exponential mapping. Remember that in exponential mapping, our main focus is on the codomain, not the domain. So we don't really pay much attention to what is happening in the domain. What we care about is what is happening in the codomain. For linear mappings, constant elements in the domain and codomain, consecutive elements in the domain and codomain must give the difference must be the same. For exponential mapping, our focus is on the ratio of consecutive elements in the codomain. So the ratio between consecutive elements in the codomain for an exponential mapping must be constant. Let's look at an example of an exponential mapping. So we are concentrating on the codomain, not the domain. You know that from here the difference is constant, which is 1. But when you come here, difference between 1 and 3 is 2. But difference between 3 and 9 is not 2, it's 6. So straight away you can see that this is not an example of a linear mapping. This can't be a linear mapping. So you start to think of an exponential mapping. Now, 3 divided by 1 is 3. 9 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27 is 3. So you can see that if you take consecutive elements, the ratio between consecutive elements are also the same. Now this is what we refer to as an exponential mapping. When you have a mapping like this, we say that you have an exponential mapping. In the previous video, we saw how to find the rule of a linear mapping. Now let's look at how to find the rule of an exponential mapping. The rule for an exponential mapping with elements in the domain denoted by x and elements in the codomain denoted by y is given by y is equal to ar exponent x minus b, where a and b are constants. Now I'm going to explain this to you. What this means is that if you have an exponential mapping where elements in the domain are represented by x and elements in the codomain are represented by y, the rule is given by y is equal to ar exponent x minus b. Now how do we find this? We know that y and x are the variables, so what we have to find are a, r and b. How are we going to find that? A is the first term of the elements in the codomain. So if you have an exponential mapping, we are saying that a is the first term of the elements in the codomain. What are the elements in the codomain? Those are what we have here. So 1, 4, 16, 64, 2, 5, 6. A is the first term of the element. So A is the first element. So in this case, A is 1. That is A. What is B? B is the first term of the elements in the domain. This is the domain. So the first element in the domain is 1. That is B. So you can pick the A and B from the mapping straight away. A is the first term of the elements in the domain, and B is the first term of the elements in the codomain. Now what we are left with? R. Remember, we are finding A, R and B. We found A and B. How do we find R? R is the common ratio of the elements in the codomain. So here the common ratio. How do you find the common ratio? You take a number here, or take an element, and you divide it by the previous element. So you take 4, you divide by the previous element here, which is 1. And since that is constant, it will be the same for all of them. You can choose to take 16, you divide it by the previous element, you are still going to get 4. So here the common ratio, R represents the common ratio. So we found A, we found B, we found R. We now have our rule. Let's pick some examples and see how this goes. Find the rule of the following mapping. We have A, B, C. We are going to pick them one after the other. Let's pick the first one. So we have x mapping to y, then the mapping has been given to us. Once again, whenever you have a mapping, you have to check whether it is linear or exponential. We know this is exponential because we are finding the rule of exponential mapping. But when it's given to you, they are not going to specify in the question that it's linear or exponential. You have to check. You've seen how to check for a linear mapping, and you've seen how to check for an exponential mapping. Now let's see how to find the rule. I'm going to write it here so that you'll be able to write our solution here. So we write the general rule. The general rule says that y is equal to ar exponent x minus b. Now what is A? A is the first element in the domain. So in this case, A is 1. Sorry, A is the first element in the codomain. So in this case, A is 1. What is B? B is the first element in the domain. That is also 1. So this is B. What is R? R is the common ratio. How do you find the common ratio? You pick an element in the codomain, you divide it by the previous element in the codomain. So 4, you divide by the previous one, which is 1. So 4 divided by 1. Somebody can decide to pick 256 divided by 64. But you can see that obviously it's easy to deal with 4 divided by 1 than dealing with 256 divided by 64. That's why it's always advisable to pick the first ones, because usually those numbers are smaller and they are very, very easy to handle. So we found A, we found B, we found R. You just substitute them into the equation. So A is 1, so we have 1 times. R is 4, so 4 exponent x minus B is 1, so 1. So this is going to give us, remember, 1 times any number is the same number. So 1 times 4 exponent x minus 1 is the same as y is equal to 4 exponent x minus 1. It is that simple. So with this rule, you can find any x value when y is being given to you, or you can find any y value when x is given to you. All you need to do is to substitute it here. So let's say after you have done this, the question tells you to find y when x is, let's say, 20. All you need to do is to change x and replace 20 with x here. So you are going to have 4 exponent 20 minus 1, which is 4 exponent 19, and you'll be able to find y. It is very, very simple. Let's look at the next example. We have this mapping here. So x maps onto y. So we quote our general equation. The general equation says that you have y given a r exponent x minus b. What is a? A is the first element in the codomain. The first element in the codomain is 1. What is b? B is the first element in the domain. In this case, b is 0 because the first element in the domain is 0. What is r? R is the common difference. So I said the common difference, sorry. R is the common ratio. How do you find the ratio? You take an element in the codomain and you divide it by the previous element. So you take an element, let's say 3, you divide it by the previous element, which is 1. Once again, you can divide to take 27 and divide it by 9. I choose to take the first two because the numbers there are smaller. So 3 divided by 1 will give us 3. After this, all you need to do is to replace or substitute what you have here into the general equation. So this is going to give us y is equal to 1 times 3 exponent x minus 0. Since a is 1, b is 0, and r is 3. And this will give us y is equal to 3 exponent x. And this is true because if you put x is equal to 0, you are going to have 3 exponent 0, which is 1. So y will give us 1. When you put x is equal to 1, you are going to have 3 exponent 1, which will give us 3. When you put x is equal to 2, you are going to have 3 exponent 2, which is 9. When you put x is equal to 3, you are going to have 3 exponent 3, which is 27. The same thing applies to 3 exponent 4, which is 81. So after you found the rule, you can even use the mapping that have been given to you to check whether your answer is right or not. Let's look at the last example in this video. So you have been given this mapping here. I'm going to shift it here so that you can write our solution for you to see it very well. We quote our general rule, which is y is equal to a r exponent x minus b. Now what is a? A is the first element in the codomain. The first element in the codomain is 32. So you are going to pick 32. What is b? B is the first element in the domain. The first element in the domain is minus 1. So you pick that. What is r? R is the common ratio. How do you find the common ratio? You pick the first element, you pick an element and you divide it by the previous element. So here I'm going to pick 16 and divide it by the previous element, which is 32. So I pick 16, I divide it by the previous element here, which is 32. So nothing changes, you follow the same format. I simplify 16 over 32 and I'm going to get 1 over 2. Once again, when you come here, it could have been easier if I pick 4. It could have been easier if I pick 4 and 2, because 2 divided by 4 will also give me 1 over 2. Very, very easy. I decided to pick 16 over 32 because I like picking the first two elements. Now let's continue. So what we do is that we replace every element here. We replace what we have found in the equation. So we replace a with 32, we replace b with minus 1, and we replace r with 1 over 2. So let's move on. So we have 32 times R is now 1 over 2. I brought the bracket because it's a fraction. So 1 over 2, then exponent x minus, remember there's minus here, and the b coming is also minus, so I'm going to have x minus minus 1. Now let's proceed. We know from indices that 32 is the same as 2 exponent 5. 2 exponent 5 will give you 32 times, whenever you have 1 exponent 1 over 2, you can write it as 2 exponent minus 1. If you watch the video on indices, you are going to understand how this is done, why this is so. So you have half being the same as 2 exponent minus 1. There's already this here, which is x minus minus 1, which will give us x plus 1. So 2 exponent minus 1 will multiply s plus 1. Watch the video on indices and you get how this computation is being done. Now this is going to give us y is equal to 2 exponent 5 times 2 exponent minus 1 times x will give us minus x, minus 1 times 1 will give us minus 1. Now from indices, we know that when you have two numbers multiplying and they have the same basis, you can add the exponents. So here, since we have 2 and 2 here, we can add the exponents. So we add 5 to minus x minus 1, and that will going to give us 2 exponent 5 minus x minus 1. And this, if we simplify, we are going to have 2 exponents. Y is equal to 2 exponent 4 minus x. So you see, when you get to this side, it's indices from here. So if you watch the video on indices, you see how all these computations were done. So what you have to understand is how to find the a, how to find the b, and how to find r. From there you can proceed with the computation. If you are not so clear on how this calculation was done, watch the video on indices and you see how to do these computations. You can also try other examples and you'll be able to solve rule for exponential mapping. So with this rule that we have found here, you can find any x value when y is given to you, and you can also find y values when x is being given to you. Thank you for watching this video on exponential mapping. See you in the next video, where we will consider a slightly different type of mapping. In this type of mapping, they are neither exponential nor linear. When you have that, we are going to learn how to find the rule of such a mapping. Bye bye.